Okay, I'm going to go over the study guide for Unit 9. Trigonometry. Okay, for the first one, if angle R is your reference angle, that means I'm standing right here, and I want to label opposite, adjacent, and hypotenuse. Hypotenuse is always opposite the 90-degree angle. The side opposite is on the other side of my little stick man, and then adjacent means next to. So we have opposite is QS, adjacent is SR, and hypotenuse is QR. Okay, for 3, 4, and 5, what is the tangent of angle D, which means this is my reference angle here. This is hypotenuse, what's opposite and adjacent. Tangent is opposite over adjacent, so we have 13 over 9. Sine is opposite over hypotenuse, which is 13 over 15.8. And cosine is adjacent over hypotenuse, so we have 9 over 15.8. Okay, number 9, explain which trigonometric ratio to use and why, then proceed with finding the height of the building. So the height of the building is going to be how tall it is, the height, and then I can figure out which trig ratio to use. So my reference angle is going to be 50. I have my hypotenuse, opposite and adjacent. So what I'm looking for is opposite, and I have information for adjacent, so I want to use tangent of where I am, which is 50, equals opposite, which is what I'm looking for, divided by 20. Now to solve for x, I'm going to multiply 20 to both sides. So x is now isolated, so 20 times the tangent of 50. And we're going to multiply this in the calculator, and this helps us find the height of the building. Use Desmos. So using Desmos, 20 times the tangent of 50 gives us about 23.8. So x equals about 24 feet. And you guys can do the next one. For 10, find the complementary angle of cosine and explain why. So complementary is what adds up to give us 90. So 70 plus what gives us 90? So that has to be 20. So the complement of cosine is sine, and the complement of 70 is 20. So on a calculator, we can check and see that the sine of 20 equals the cosine of 70. So sine 20. Sine 20 is 0.3420, and the cosine of 70 . So again, sine of 20, cosine 70. They're the same. And you guys can explain why. And then do the same for 11. Alright, for 12 and 13, what is LK rounded to the nearest hundredth? So this is my hypotenuse, opposite, adjacent, and I'm looking for LK, so that's going to be where I put my variable. I can use something that has opposite in it, and I have no information for adjacent, so I need to use the hypotenuse. So I can set up the sine of 35 degrees equals x over 9.5. And to solve for LK, which is x, I'm going to multiply by 9.5 to both sides. Then x equals 9.5 times the sine of 35 degrees. So I'm going to use Desmos. 9.5 times the sine of 35 degrees is 5.44. It says round to the nearest hundredth, so x equals 5.448, so 45 hundredths meters is LK. What is JK rounded to the nearest hundredth? So now I'm looking for adjacent. So I can use the cosine of 35 degrees equals adjacent, so I'll call this y, over 9.5. And the same to solve for y. Multiply 9.5 to both sides. Y equals 9.5 times the cosine of 35 degrees. 9.5 times the cosine of 35 degrees is 7.7819. So if I'm rounding to the nearest hundredth, this is going to be 7.78 meters. I'll do 17 and 19 on these two. This is a 45, 45, 90 triangle. So the pattern is that these legs are congruent because two angles are congruent. So this is square root of 8. And then I can use Pythagorean theorem to find what the hypotenuse is using a squared plus b squared equals c squared. So when I square something that's being square rooted, I just end up with whatever's inside. This is 16 equals c squared. You undo a square by taking a square root, so c is 4. So those are the missing side lengths. For 19, the hypotenuse is 2 times the smallest side. So half of 20 will give me 10. And then 10 times 3 is 30. Square root of 3 is the pattern. And the last one, 20, explain how you find a degree of angle A. So if I'm looking for what the angle is, I need to set up a trig function. So this is hypotenuse, opposite, adjacent. I have information for opposite and adjacent, so I can use tangent of angle A equals opposite over adjacent. And in order to find what this angle is, I need to undo the tangent with a tangent inverse to both sides. So this gives me angle A equals the tangent inverse of 5 divided by 12. So tangent inverse of 5 over 12 is 22.6. So angle A is about 23 degrees. About 23.